Okay, so this is the same problem which we have solved in the class. There is no difference in the problem. What you have to understand that there is a motorboat and it can travel 30 kilometer upstream and 28 kilometer downstream. And how much time it takes to do both these journeys? In 7 hours total. So this much information gives us our first equation. But before we get to that, let's assume what is our x and y. So as we have done earlier, we'll assume the speed of the boat in still water to be x. Okay, and speed of boat in still water is x, and what will be the speed of the stream? Let's call that as y. Okay, so if we have the speed of the boat in still water and the speed of stream together, combining these two, we can find out what will be the actual speed of the boat while going upstream and what is the speed of the boat while coming down. So let's write down those things. Speed of the boat upstream, and we had talked about it. When the boat is going upstream, the stream is flowing against it, so the overall speed will get reduced, right? So the actual speed will become x minus y, this much kilometers per hour. And speed of the boat while going downstream, the stream is helping the boat to go faster, so the speed will increase and it will become x plus y kilometers per hour. So once we have the speeds and the distances, see, distance and time is already given: 30 kilometer upstream, 28 kilometer downstream, and how much total time it took. So we'll use the speed, distance, time formulas to create our first equation. So for the first part of the journey, what we have to do is we have to find out how much time it took to go upstream. So when it was going upstream, how much distance did it cover? It covered 30 kilometers upstream. So the total time will be distance by speed, right? Time is equal to distance by speed. So you should remember that time is equal to distance by speed. So let's use that logic. So while going upstream, the distance was 30 kilometers and the speed was x minus y. So this is the time taken to go up. But we don't know how much time individually it took to go up alone, right? So we only know that it took 7 hours to go upstream and then downstream 28 kilometers. So let's add those two times together. So what will be the time to come downstream? It was 28 kilometers. So distance is 28 and speed while coming down was x plus y. So this is the time going upstream. This is the time going downstream. So when we add them together, the question says that it took a total of 7 hours. So that is what gives us our first equation. So using the same logic, we will do the second part of the question. What does it say? It says that it can travel 21 kilometers upstream. So this time it went 21 kilometers upstream and return. So what does the word return means? So it went 21 kilometers upstream. So it has to, of course, come back same 21 kilometer down again, right? So this time it has gone 21 kilometer upstream and down also, even though it's not mentioned here, but the word return, it means that the downstream also, it has come back 21 kilometers and it has taken 5 hours to do this. So let's do the (21 kilometer upstream), speed would have been x minus y, and same 21 kilometer returning down backwards with the speed of x plus y. So this is a total time to go 21 kilometer up and 21 kilometer down. And it has taken 5 hours to complete this. Okay. So now we have our equations and we have solved problems like this before. So assume one of them to be A and another one to be. So let's say 1 by x minus y, I'm going to call it as A. So you can call 1 by x plus y also as A, 1 by x minus y also as A, anything, okay? So let it be 1 minus A. 1 by x minus y is A. And 1 by x plus y is equal to B. So let's rewrite the equations 1 and 2. 1 by x minus 1 means, see there is 30 by x minus 1. I can write it as 30 into 1 by x minus 1. No? So it becomes 30 times of A. And this becomes 28 times of B. So the first equation will become 30A plus 28B. 30A, 28B is equal to 7. Since we have written in a different form, let me give the new name to it. Let's call it as equation 3. And second equation, what would it become? 21A plus 21B is equal to 5. So now you have your pair of equations in two variables. Instead of x and y, we have the variables A and B over here, okay? But the logic is same. You'll solve it using the same logic, either elimination, substitution, or cross multiplication, whatever method you like, you can solve it. Okay, so to solve this, I'm seeing that this is a factor of multiple of 7. This is also a multiple of 7. How can we make them equal? By multiplying something. If we multiply something, the numbers will become very big. Can we divide by something to make it equal? Okay, so what I would do is I would divide this third equation by 4. So if I divide it by 4, what will happen? 28 divided by 4 will become 7b. And this fourth equation, I will divide it by 3. So this will also become 7b. Divide the third equation by 4. Divide the fourth equation by 3. But if you are not comfortable with dividing, you can do it using the normal methods which we have learned earlier. You can find the LCM of the two numbers and make them both equal to that number. Okay, so you know how to solve these equations, so I'm not going to go too much detail into that. So just try to solve the equation on your own, but for here I will solve it using this method. Okay, because I see that it's better to divide it instead of multiplying. So dividing third equation by 4 and fourth equation by 3 and subtracting. What do we get? So let's first do the division of third equation by 4. So it will become 30 by 4 A. 30A by 4, no? So that's what I'm writing it as, 30 by 4A. Okay, or let me write it as 30A by 4 itself. First term divided by 4. Second term also, 28B will be divided by 4. And 7 will also be divided by 4. So simplify it. So I'm going to directly write it as 7B, okay? And this also you should be able to simplify. So what can I write? 15 by 2, right? 15A by 2. And this, let's leave it as 7 by 4 itself. By 4 became 15 by 2. Fourth equation, we are dividing by 3. So it will become 21 by 3. It will become 7A. plus 21b will become 7b, and this will become 5 by 3. Now if we do the subtraction, let's change the sign. So 7b and minus 7b will become 0. Just do the subtraction of this. 15 by 2 minus 7a. So I can take a common and write it as 15 by 2 minus 7 times of a is equal to 7 by 4 minus 5 by 3. Simplify this. It will become 15 minus 14 by 2 a. And what is this? Cross multiply. 7 3s are 21. 5 4s are 20. And 4 3s are 12. So this is basically a by 2. 15 minus 4 will become 1. So 1 into a will become a by 2. And this is also 1 by 12. Send this 2 transpose to the other side. It will become a is equal to 2 by 12. When you cancel it, it will become 1 by 6. So now we know a is equal to 1 by 6. Okay, now if a is 1 by 6, then we know that 1 by x minus y is equal to 1 by 6. So what does it imply? X minus y is equal to 6. No, we can do a reciprocal of this, and x minus y will become equal to 6. So let's give it a name, equation 5. And a is equal to 1 by 6. This is what we are going to substitute in the any of the equations. A is equal to 1 by 6. So as you can see, if I put a is equal to 1 by 6 in the first equation, instead of a, if you put 1 by 6, 6 5s are 30 will get cancelled. No? The calculation will become slightly easy. So let's pick the third equation for substituting the a value. Substitute a is equal to 1 by 6 in the third equation. So instead of 30a, I'm going to write 30 into 1 by 6. In place of a, I'm writing 1 by 6. What is the other remaining part of the third equation? 30a plus 28b plus is equal to 7. Plus 28b is equal to 7. So let's write that. So 6 5s are. So this term become 5 now. Send this 5 to the other side. 7 minus 5 will become 7 minus 5 is 2. And this 28 I can transpose down. So it become 2 by 28, which will cancel it to become b is equal to 1 by 14. Now, if b is 1 by 14, we know 1 by x plus y is also 1 by 14. So we can write x plus y is equal to 14. And this becomes our sixth equation. So since x plus y and x minus y, we know we have come up to this situation many times. X minus y is 6 and x plus y is 14. So this is again another pair of linear equation in two variable. And we have to solve it. How do we do? Eliminating y is very easy. If I just add equation 5 and 6, minus y and plus y will become 0, right? So just add equation 5 and 6. And for you to make sure that you see it easily, let me write that x minus y is equal to how much? 6. X minus y is 6. This is our fifth equation. And x plus y is equal to 14. That is our sixth equation. So this is what we are solving now. Okay. So you see minus y plus y, they'll get eliminated easily. So just adding equation 5 and 6. These two become 0. X plus x becomes 2x. And 14 plus 6 becomes 20. So x is equal to 20 by 2. That means x is equal to 10. Now remember, what was this x? X was the speed of the boat in still water. So this was speed, right? So we'll write it as kilometer per hour, as we assumed it to be 10 kilometers per hour. Then now we know x, so we can find y very easily. X plus y is 14. So put the value of y in that. So x plus y is equal to 14. Means in place of x, you put 10 plus y should be also 14. So transpose 10 to the other side, 14 minus 10. So y is equal to 14 minus 10. So y is 4 kilometers per hour. And remember, what is this y? It's the speed of the stream. So as a final conclusion, you will write, so speed of boat in still water is x, that is 10 kilometers per hour. Four kilometers per hour. Okay. So your other question is exactly same. There is no difference. In the first one, at least that word return was mentioned over here. So only thing you had to figure out that the person had gone 21 kilometers upstream and then 21 kilometers downstream. Eighth question is very straightforward. 32 kilometers upstream, 36 kilometers downstream in 7 hours. And in the second case, 40 kilometers upstream and 48 kilometers downstream in 9 hours. So just you'll form your equations and solve them in the same way, just like we did the seventh one.